students, welcome back. In this part of video, we are going to study about gravitational field, gravitational potential energy, and the calculation of gravitational field and gravitational potential at various points. So let's start. Hello students, welcome back. Now we are going to start gravitational field and gravitational intensity. Gravitational field. Whenever a mass is kept at a point, then it creates a gravitational field in the space around it, and this is known as gravitational field. And whenever other mass comes into this field, then it exerts a gravitational force, and we know that gravitational force is attractive in nature. Now gravitational intensity, it is denoted as E. To measure the strength of gravitational field, we define a parameter known as gravitational intensity, and it is a vector quantity. And the SI unit is Newton per kg. The meaning is, this is the mass, may be taken as Earth or any mass. So this is a mass, and let us consider that this Earth is kept in a space. Then according to this definition, it creates a gravitational field around it in the space, and whenever other mass comes into this field, this is the mass, other mass comes into the field of this mass, then it exerts a force. Okay, and this is the force is gravitational force and attractive in nature. Now, to measure the intensity of this gravitational force per unit mass, we define a parameter that is called gravitational intensity, and it is a vector quantity. Since force is a vector quantity, and if we divide force by mass, means force per unit mass, okay, Newton per kg, force per unit mass is called gravitational intensity. The gravitational intensity at a point is defined as force experienced by per unit mass at required point. Okay, now this is the mass, okay, and a point mass here, this is the point mass or unit mass, is kept at distance r, then it feels a force on it due to this. Okay, so the force due to this mass on here can be explained at when a mass m comes into gravitational field E, and this is, let us consider the gravitational field created by this unit mass is E, and now consider this mass m comes into gravitational field of this. Okay, so it exerts a force on this mass m, and this force is, and the force magnitude of force is equal to here me, where m is the mass of entering mass or other object, okay, and E is the intensity, gravitational intensity of first mass. Okay, now in the vector form it can be written as, since E or gravitational intensity is a vector and F is a vector, so F vector is divided by mass, it will give an gravitational intensity in form of vector, and we can put here force gm1 m2 by r square, and this will give E is equal to gm by r square. So this is the important formula for a point mass. Okay, intensity due to point mass, when mass m comes into an gravitational intensity E, then force exerted by or force experienced by mass m is F is equal to me. Okay, now let's proceed. Gravitational potential. The gravitational potential at a point gravitational potential at a point due to a mass is defined as work done by external agent in bringing unit mass slowly from reference point to the given point. That is gravitational potential at a point. Now let us consider we have to define a gravitational potential at distance r here at point P. Okay, so a unit mass work done by external agent on unit mass in bringing from reference point or infinity to the required point. The work done in bringing this unit mass from reference point or infinity to the required point here by the external agent is called gravitational potential. Now here m, this is the mass m and this is the unit mass. Since this is the both are mass and the force here, force is gravitational force and is nature is inattractive. Okay, so the direction of force due to field is in this direction. So due to external force is in this direction. So the gravitational potential is equal to, gravitational potential can be denoted as V, and it is V is equal to minus Gm by R. V is a scalar quantity and the unit is Newton meter per kg, or Newton meter can be written as joule, so joule per kg. Okay, now we are going to derive how to find potential. Since I already explained that work done by external agent, gravitational potential is work done by external agent in bringing unit positive charge from infinity to the required point. So we have to find work done by external agent, and this value will give the gravitational potential. So now we know that work done, small work done is equal to F dot dr. Okay, here F is equal to F external, we have to take F external, work done due to external. So here F external is in this direction, I or x axis. Okay, so here F, it can be written as, this is the F external is equal to F field. Okay, and the value is same as force of gravitation, G m1 m2 by r square. Here m1 is m and m2 is 1. So F external, the magnitude of F external is G m by, what is the distance? Distance is x. Okay, so G m1 m2 by r square, this is the magnitude, and direction is I cap. Okay, and the dr is, this is the initial position, xi is equal to x. Let us consider this mass moves from here to here, new position is this, so this is the dx. Okay, so this position, this value can be written as xf is equal to x minus dx. Okay, x minus dx. So here dr can be written as final minus initial. So x minus dx, final minus initial value is x, so x. Okay, this is the final position, so final minus initial, this is the initial position. Okay, so final minus initial, and the displacement is initial to final. Displacement, what is displacement? Displacement is, can be written as x final minus x initial. Okay, and direction of displacement will be initial to final. So initial, this is the initial position, this is final. So initial to final, this is the direction of displacement, that is minus I. So here minus I cap. So this will be cancelled, and Gm by x square and this is minus 1 is positive, so I dot I, okay, so into dx, and the I dot I is 1, so gm by x square into dx, and gm is constant, so dx by x square, so w total is equal to gm, this can be written as, this is from infinity, from reference, we are moving from reference to this r value, so infinity to r value, and this is how much, integration of dx by x square is minus 1 by x, okay, so from infinity to r, so this will give gm by r with negative sign, and this work w external can be written as v, okay, so this is the value. So gravitational potential, this way we can find the gravitational potential at a point, okay, gravitational potential at a point, this is the value, is v is equal to minus gm by r. Now gravitational potential energy, gravitational potential energy can be represented as u, denoted as u, and it can be defined as work done by external agent to assemble the system of masses from reference point. Let us consider that this is the point 1, mass 1, this is the point where we want to bring mass 1 from infinity, bring this mass from infinity to this point, okay, point 1, point 2, point 1, and bring other mass from infinity to here. So now this is m1, this is m2 new position, and the distance between them is r. So the meaning is work done by external agent to assembling the system of masses from reference point, okay, means we are collecting the masses from infinity to a particular point, okay, we are bringing from infinity to a particular point, we are bringing from infinity to here this mass, and for this mass we are bringing from infinity to here, so we are assembling masses from infinity to a particular position, and the new position here, this is the new position of mass m1, this is the new position of mass m2, so there is a gravitational potential energy between these masses at new position, and this can be found by work done by external agent bringing masses like this mass from infinity to here, we have to find work done bringing m1 from infinity to here and m2 infinity to here, and this value will give u is equal to minus g m1 m2 r. R is the distance between the new position of masses, m1 m2 the masses, and g is the gravitational constant, and u is a scalar quantity, it is a gravitational potential energy is a scalar quantity, and the unit is Newton meter or joule, okay, since it is energy, so SI unit of energy is joule or Newton meter, okay. So now let's proceed. Relationship between gravitational field and gravitational potential. What is the relation between E and V? So since we know that E is equal to F by M, gravitational field is equal to force by mass, and it can also be written as gm by r square. In the previous we have already seen that is F is equal to me, this is equation 1. Now we know that work done is equal to dot product of force and displacement. Other equation we know that work du is equal to minus dw, okay, potential energy is equal to negative of work done, and gravitational potential is equal to gravitational potential energy divided by mass. So using these four equations, we have to solve this, and we will find the results like this. Ex is the gravitational field in direction of x. So this is the relationship between gravitational field and gravitational potential, and the final relation is Ex is equal to minus partial derivative of v with respect to x, Ey is equal to negative of partial derivative of v with respect to y, Ez is equal to negative of partial derivative of v with respect to z, and this is the relation we have. This is the relation between E and V, and here we are finding E. We are finding gravitational field from gravitational potential. So we can find gravitational field by differentiating gravitational potential. So we know that the reverse of differentiation is integration. So now we can find gravitational potential from gravitational field by integrating this. Okay, so this is the relationship between gravitational field and gravitational potential. Gravitational field, for the gravitational field this is the equation, and for gravitational potential this is the equation. Gravitational potential is equal to negative of differentiation of E dot dr from R0 to R1. So this is the important equation we have to keep in mind. Now, calculation of gravitational field and gravitational potential. Now we are going to study calculation of gravitational field and gravitational potential at various masses, various types of masses, and let us consider case 1 or case A, calculation of gravitational field or gravitational potential due to a point mass. Let us consider this is the mass and this is at r distance, there is a unit mass or point mass. So due to this mass m, here gravitational field is equal to gm by r square in magnitude, and the direction is here, negative sign represents the direction, r cap is the unit vector along AB like this. But we know that these two are masses, so it is attractive in nature, so the direction of force will be this. So this represents the negative sign. The negative side represents the direction of this vector gravitational field. So the magnitude of E magnitude की बात, for E magnitude is equal to gm by r square. This is the magnitude. Okay, and V is equal to minus gm by r. These two equations we already studied in previous slides. Now this is the question 1. We are going to solve this question. Here gravitational potential, the gravitational potential due to a mass distribution. This is the gravitational. V here given is V. Now find gravitational field. We have to find E. So V is a function of x. According to question, V is equal to function of x. So Ex is equal to negative of dou V by dou x. So just negative of differentiate this V. So dou by dou x, a into x square plus a square power minus 1 by 2. So we have to differentiate this with respect to x, partial derivative. So minus, so a is constant, so we can take it out. So differentiation of this with respect to is x to the power n. So the differentiation of x to the power n is equal to, we know that since differentiation of x to the power n is equal to n into x to the power n minus 1. So here n is equal to minus 1 by 2. So minus 1 by 2, the value of x is x square plus a square, and minus 1 by 2 minus 1, okay, into differentiation of this part is 2x. Okay, so go ahead, minus a inside is my 2 cancel, so minus x by x square plus a square power 3 by 2. So the final value is ax by x square plus a square power 3 by 2. So this is the ex, this is ex. Since v is only function of x, so the value is only for ex, and ey is equal to 0, also ez is equal to 0. Okay, we are using previous formula, the relationship between gravitational potential and gravitational field. Now, two small bodies of mass 2 kg and 4 kg are kept at rest in a separation of 2 meter. So this is 2 kg, this is mass 4 kg, third mass is placed here 0.1 kg, and according to question, this mass third mass 0.1 kg we placed in such that it will experience no net gravitational force, okay, due to these two bodies. So this and this, okay, A, B, C. So force on C due to A, force on C due to B will be equal, and we have to find gravitational potential energy. So we have already solved this part of this question in previous slides, and we have already found x is equal to 0.83. This distance is 0.83, and from this side, so this will be 2 minus 0.83. 2 minus 0.83. This will be the value. Okay. Now we have to find gravitational potential energy of the system. So gravitational potential energy of the system is equal to gravitational potential energy of the system is equal to gravitational potential energy between AB plus GPE, gravitational potential energy between AB AC plus GP, gravitational potential energy between BC. So this is the three cases we can go through. So find what is the value. Gravitational potential is equal to minus U m1 m2 by r. So minus G, m1 m2 means m1 is 2 kg, m2 is 0.1, m1 m2 by r is 0.83. Okay, this is GPE for first, AC for AC, this is for AC, this is for AC. Okay, and for AB is minus G, m1 is 2, m2 is 4 by r is 2, plus this is for AB, and for BC minus G 0.1 into 4 by 2 minus 0.83. Find this value. This will be the this will be minus x joule. This is the gravitational potential energy of the system. So this is the end of the part. We will continue in the next part. Stay tuned. Thank you. So students, we have discussed about gravitational field and gravitational potential. Here we already discussed about definition of gravitational field and gravitational potential, as well as its formula and its derivation. And we have also discussed about gravitational potential energy. So in the next part we are going to calculate gravitational potential and gravitational field at various points. So stay tuned.